Okay, so you'll have like a lot of views or be very popular or whatever, right? Okay, good. All right, so we're going to compare linear, quadratic, and exponential patterns. Most of you probably already started this, but I want you to take a second and I want you to look at these two tables. One of them is linear, one of them is quadratic, and one of them is exponential. Okay, your job is to figure out which one. So you're going to find the first difference and then find the second difference between all of these. Okay, so take a second, try the YouTube, the TikTok, and the Instagram. Find the. So if you found the first difference, that's 20 minus 10. That's going to give me 10. 40 minus 20 is going to give me 20. 80 minus 40 is going to give me 40. We're going to subtract the first differences. So 20 minus 10 is 10. 40 minus 20 is 20. Notice how the first difference is not the same. Second difference is not the same. Oh. Okay. So we see that the first and second difference are not the same. So what are we multiplying by each time? 2. So this guy's going to be exponential. Okay. Down at the bottom, what is this number going to be then? 160. Everybody see it? Okay. On the next one, if we find the first difference, that's 50, 50, 50. We see that the first difference is all the same. What kind of function is that? Linear. That means that this box is going to be what? 210. Okay. The last one, we find the first difference. They're not the same. But if we find the second difference, they're the same. What's this one called? Okay. Now, this is the tricky part. How do you find that empty box? Well, you've got to repeat that pattern, right? So from here to here, it's got to be 10, which means that this has to be 35. So everybody see that? And so then in order to get this box, you're going to do 55 plus 35, and that's going to give me 90. Who do you think went viral? Looking at your table. Some people are saying Sam, some people are saying Justice. Okay, if we actually continue the table, this is what it looks like. Who actually went viral? Sam. Okay, because he's growing exponentially. Okay, exponential is going to have the fastest average rate of change over the longest period of time. Okay, now shortest period of time, it's kind of a toss up between these two, but I think Justice wins. What? Say it again. For the last one, it's a quadratic. So we had a first difference are all the same. I'm sorry, first difference are all different. And then the second differences are the same. Yeah. There's not like a consistent one. Quadratics are a little different. Average rate of change is on the back. There we go. Lord. Okay. Average rate of change is on the back. Reminder that this is your formula. Okay. If I say for the first 3 hours, that means from 0 to 3. So 0 is going to be your x1, 3 is going to be your x2. Okay, so go ahead and find your average rate of change. Take a moment. That's what you're working on. All right, so on your mastery check, you will be asked to graph, as well as a couple other questions. So we're reviewing for the mastery check. So get ready. Okay, on here, exponential functions have the form, and we talked about this on Tuesday, but just as a refresher, a times b raised to the x, where b and x are any real number. And that means that we can plug in any number for x, and we can plug in any number for b. Okay. Domain is always going to be negative infinity to positive infinity. Unless it's like in context, always going to be negative infinity to positive infinity. Okay. Range, however, is going to depend on what your b value is. So y is going to be greater than your asymptote, or y is going to be less than the asymptote. Okay. We also talked about growth, and we talked about decay. And that's where b is bigger than 1 and b is less than 1. equation right here. We got 2 to the x. We're going to plug in all these numbers into this equation. Okay. So we're going to plug in -2 in for x. We're going to plug in -1 in for x. We're going to plug in 0. We're going to plug in 1. We're going to plug in 2. We're going to plug in 3. On your mastery check, it will already have the table filled out for you, but this is how you create it. If you plug in 2 raised to the -2 power in your calculator, what do you get? Not -4. 2 raised to the -2 power. Type it in your yellow calculator. Type it in, type it in. Okay, so 2 raised to the -2. 2, oh yes, go grab the yellow calculators. 2 raised to the -2, what'd you get? 0.4, what'd you get? It should be like 0.25 or 1/4, yeah? Okay, 2 raised to the -1st. That should give you something like 0.5. 2 raised to the 0, that's gonna give you 1. 2 to the 1st, that's gonna give you 2, then 4, then 8. Okay, first question for you. Is this exponential or is this linear? Which one? How? Because we're multiplying by what? We're multiplying by 2 each time. Does everybody see that? Multiplying by 2 each time. Yep. Okay. What is the y-intercept of this guy? Okay, and I want you to write it as an ordered pair. So 0, 1. That comes from this table right here. Okay. If I asked you for the domain of the first 5, like, let's say this is talking about hours. So from 0 to 5, what would the domain be? If I asked you for the domain from 0 to 5, what would the domain be? This is not a trick question. I just told you the answer. If I asked you for the domain from 0 to 5, what would be the domain? 0 to 5. Does that make sense? So if I said like the first 5 hours, that would be from 0 to 5. If I asked you for the range, however, what we're going to do is we're going to look at 0, what's our y value? And then we're going to go all the way to 5. Well, it doesn't have that on the table, right? So we've got to extend the table. What would be the next number? And then the next number? Does that make sense? So we would have from 1 to 32. Which, okay, so when you graph this, you got something that looks like this. Like that, right? Okay, I'm not looking for perfection in graphing. I'm looking for, can you plot like 3 points and then connect the dots? Cool. Now, is this increasing or decreasing the entire time? Increasing. Okay, I want you to try this next one, that 4 to the x. You're going to answer those same questions that we just did. So let me put that up here. Okay, you're going to answer those same questions we just did. You're doing 4 to the x, you're filling in the table and answering all these. Let's chat. Okay, we got 4 to the x. We got 4 to the x. All right, I'm going to fill in the table like right here. It's the same thing though. All right, so 4 raised to the x, that's going to give me, I don't know what 1/16 is in decimal form. On the next one, this is going to give me 0.25. Next one, 1, 4, 16. I think the next one's 64. Okay. Oh, now, what is the y-intercept? So 0, 1. You got to write it as an ordered pair on your mastery check. Okay. Is this exponential or is it linear? Exponential. Okay, why? We're multiplying by what number? 4. Everybody get on those 2 questions? No. Because you're not paying attention. Okay, the y-intercept is 0, 1, and we're multiplying by 4 each time. The way we got that is because look at the equation, or you can look at the table. Okay, so you're gonna take each one of these x's and plug it into the equation. So like 4 raised to the 0 power. So you'll hit 4, this little caret button, 0. Good. Okay. Now. Oh, no. Is this increasing or decreasing? It's increasing on the entire time, right? All right. Shh. Domain. If I asked you for the domain over the first 5 hours, 0 to 5. If I asked you for the range, what's the lowest y value? 1. And we're going all the way to 5. So on here, we're going to multiply by 4 twice. It's 256. Yeah. So that'll be my y value, my ending y value. Questions? Oh, JK. You lied to me. So 1,000 what? 1,024? Okay. 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 We're going to plug in. Oh, geez. Okay. So we're going to plug in 3 times 2 raised to the x. We're going to plug in all those junk. So this is going to give me 3 for 0. Sorry, I'm doing this in my head. 4, 12, 8, 24. And then what'd you get for these two? Okay, so when you type this into your calculator, like the yellow calculator, I would do 3 times 2, parentheses, raised to the parentheses, and then whatever number you're plugging in. So like, type this junk in and put a -2 and tell me what you get. 0.75. All right, type it in with a -1. 1.85. No, yeah, okay. Cool. Questions? Okay, so y-intercept, what is it? 0.3. Is this increasing? Yeah, the entire time, right? If I ask you for the domain, I'm gonna change it up on you. For the first 3 hours, that would be from 0 to 3, right? Okay, and so then you would tell me what the range is, and the range would be what? 3 to 24. If I asked you for 0 to 5, you would have to find that y value. So you would multiply by 2, and that would be 96. Is that right? Give me one sec. It would be 96. Average rate of change. So just a reminder for your average rate of change, this is your formula. Okay, this problem always comes up on your final exam, your interim, and your unit test. It'll be on there. Okay, now this problem says that we're talking about 1987 to 1997, right? Okay, at the bottom it says years since 1987. So each time that we go along, it's a year past 1987. So we need to find the average rate of change. So at 1987, that would have our x be 0. Does that everybody understand why? Okay, then we would have 1988. We would have 1, 2, 3, 4, all the way down. 9, 10. Okay, all the way down to 1997. Okay, so on your paper, what I would probably do is label which one is 0, 1, 2, 3. I would write this out beside because it's going to help in just a second. 8, 9, 10. Okay, now to find the average rate of change, we've got our x1, which is going to be 0. And then 1990, what number is corresponding to that? 3. Okay, so 3 is going to be our x2. Does everybody see it? Now, in order to find our y1, y2, we're going to look at our y values. So our y1 is going to be 17, and then our y2 is going to be 84. We're going to take all this information and we're going to plug it into this formula. So we're going to get 84 minus 17 over 3 minus 0. Okay, somebody plug into their calculator 84 minus 17. 67 over 3. What's 67 divided by 3? 22.333. Okay. So can you try these next two? Plugging in the right things. 0 should be 1987. And then for 1993, which is 6. So x1, x2. And then for your y1, y2, that's going to be 17 for your y1. And then for your y2, that's going to be 272. Okay. Now we're going to plug it in. I'm going to do this over to the side. So 272 minus 17 over 6 minus 0. What's 272 minus 17? 155? 255. Okay. Over 6. So 255 over 6 is what? Say it again. 42.5. Okay. All right, go ahead and take a moment, do the last one. Term and the final and all that. So this notation right here, it says let f be the function. So f of 2 represents the number of stores here since 1987 shown above. The value of f of 20 is 15,011. What does that mean in context? Okay, so what does this 20 mean? What does 20 mean? What do they define it as? What does the 20 mean? Not the f of 20. Not the number of stores. What's the other part? Number of years. Okay, so after 20 years after 1987, there were 15,011 stores. That's what this is saying. You have to be able to interpret what is going on in the word problem. This is on your EOC final exam and interim. It will be there. Okay. Now, on the next part, it says f of 20 minus f of 10 divided by 20 minus 10. Okay, so f of 20, we already know was 15,011. Okay, looking back at your part on the previous page, what is, when x is 10, what was your y value? 1,412. So we're going to plug that in for f of 10. And then in the bottom, we're going to keep 20 minus 10. Everybody see that? So instead of writing f of 20, I'm going to plug in the numbers. Okay. Can somebody type this into your calculator? Tell me what you get in the top. Okay. And then we're going to divide it by 10. So that's going to be 13599. Okay. So I don't know, 15,011 minus, okay. So this is going to give me 1359.9. Now, what does this actually tell us about the number of stores? Like, what does it tell, the average rate of change, what does it tell us? Well, it tells us between the years 10 to 20 after 1987, that each year we gain about 1,359 stores. Okay. This question is always on your final exam. Very similar. It'll probably give a different scenario though. Okay, so when you graphed all of this, okay, what you should have gotten is something that looks like this. Ta-da. Okay. Now, where do you see 1,000 on the graph? Like what, where? What's it called? Which is the y-intercept. Okay, so y-intercept, right? That's our initial filling out front. Okay. What about the 2? Where can you see that on the graph? Not the x. Like what it's increasing by. Like, look at it. We went from 1,000 to 2,000. We went from 2,000 to 4,000, 4,000 to 8,000. So we see it as almost being like the rate of change, but what it's being multiplied by. It's being multiplied by 2. So we're going to see that in the y values. We're going to see that in the y values. Okay. Okay. All right, so we're really going to focus on interpreting in context. Okay, so the cost in dollars to produce 1 watt of solar energy is a function of the number of years since 1977. From 1977 to 1987, the cost could be modeled by an exponential function. Here's the graph of the function. So what is the statement f of 9 equals 6 saying about the situation? Okay, first of all, what does this 9 represent? What does a 9 represent? Not the cost, the years. So at year 9, how much did it cost? Okay, it cost $6. Okay. Yeah. Okay, and what do these values represent in context? So when x is 4, we got 30. That means 4 years later, it's $30. Or I'm sorry, $25. Does that make sense? Exactly. Okay. Y'all got it. So great. Okay, looking at the next one. Okay. If you take this equation and you set it equal to 45, that means that we're looking at our y value at 45. What's our x? So what's x when y is 45? 2. Okay, now what does this mean in context? That means that 2 years, we got $45. Okay, by what factor did the cost of the solar cells approximately change each year? So what you're going to do is you're going to take your second point, which is 60, and divide it by 80. 60 divided by 80. Somebody type that in their calculator. 60 divided by 80. Okay, so it's going to be a factor of 0.75. So we're decreasing by a factor of 0.75. Okay. It is decay. Okay. On the next one, it says, what does it mean, A of 0 mean in this situation? So this is a new situation. We have A of 0. So reading this over, it says the area covered by a city in square miles, A of the number of years, X, since the city was surveyed in 1980. Here's the equation. What does A of 0 mean? So what does that 0 mean? So X is the number of years. So 0 number of years. So starting year, the number of square miles. Okay. What is A of 5? So what you would do in this situation is you would plug in 5 in for X. So 20 times 1.1 raised to the 5th power. Somebody type that into their calculator. Twenty times 1.5 raised to the 5th. Okay. And what does this mean in context? That means that year 5, after they've been surveyed, it's going to be 32.202 square miles. 102. Boom. Okay. Now on this last one, since we don't have the graph, what you can do is you can type this equation in and literally set it equal to 43. If you look on the graph, it crosses at 8. So you didn't even have to solve anything. Yeah. Yep. You're typing in Desmos. How do you know what to put for the X? So it says A of X equals 43. That means your Y value is 43. Remember how we did this problem where we looked at when Y was 45? We don't have the graph. So if we have this equation, we could graph it and then we can look at when Y is 43. Or we can take the equation and set it equal to 43 and itself. No, it'll tell you that X equals 8. It'll cross at X equals 8. Okay, really quick. Tomorrow is a digital learning day. That does not mean I have school off. That's not what that means. I have a 10-minute video that you need to watch. And that review guide that you picked up, that's what you're going to be working on. Don't lose the review guide. Don't lose it. Okay. So you're going to complete a couple of problems tomorrow on your digital learning day. I'll have it posted today so that you can, so that you can knock it out tonight.